I want to share with you my go-to tool for making calculations quickly and accurately and smoothly without having to wrangle over the entries in a graphing calculator, without having to open up a code and putting in a print statement. Just getting a quick and dirty calculation of multiplying and dividing a few things using scientific notation and even using units. And that is this wonderful page right here, Google. You may have some experience with using Google as a calculator. If you type in 3 plus 2 into Google, you can press enter, and it will give you the answer right here, 5. And then there's usually some search results beneath that. We're going to just ignore those because it's giving us the answer up here. Now, it does have this built-in calculator like you're probably accustomed to seeing. I almost never use this thing because you can just type whatever mathy thing you need into the search bar on Google, and it will calculate it for you. This works on the Google website. It works on mobile devices. It even works if you have an Android phone in the little Google search bar that's always on your screen. And it knows all of the mathy stuff you need. It knows order of operation, so like 3 plus 2 times 7. It knows to multiply the 2 and the 7 first to give you 14, and then add 3. It knows to do that regardless of the order that you put things in. There's 17 again. It knows division, right? So I can do, what did they give me? They gave me 17. All right, let's make that 18 by adding, if I change that 3 to a 4. I can also divide, right? So just like on your graphing calculator, you can put parentheses around a quantity. That's going to give me 18. We can divide 18 by 2 to get 9. So here it is doing the order of operations. It is taking the 2 times the 7, it's adding the 4, it's grouping all of that together, and then dividing the whole thing by 2. Of course, you can probably imagine I can group the denominator as well. So I can make this 2 times 9, for example. And there I've got 1 because I'm taking 18 and dividing it by 18. Of course, it doesn't have to be a whole number. It can handle decimals just fine. So there's a 1.125. It can, you can make your numbers however big you want. Let's say I'm dividing by 8, 1, 2, 3, 800,000. I can do this. It will spit out the decimals just fine. I can keep going bigger without a problem. And Google knows scientific notation. So it will start kicking this out in scientific notation around the time you get past a million or a million, something like that. It uses this little e to represent times 10 to the. So like you've seen in Python, E here just means times 10 to the, right? So when it has this 1.125, E negative 9, you are taking the E and replacing it with this times 10 to the. It's much more compact than times 10 to the. This is a standard notation. If you're not accustomed to seeing that, you'll want to get used to that because that's how a lot of computers will represent scientific notation, is with an E. It will also accept scientific notations. Like for example, here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. I can put in 8E9. And this is really how you should be writing large numbers in Google, is with scientific notation, because you don't want to have to count those zeros. Counting those zeros on the screen is where you're going to introduce an extra factor of 10 or miss a factor of 10. And then this scientific notation, this power of 10 here, is going to be off. Right, so you just put in the 8E9 and it interprets that as 8 times 10 to the 9. You do not have to put in, I see students do this a lot, they'll put in 6.67 times 10 to the negative 11, and then they start panicking because they need to put in these parentheses here, and I better put parentheses around this whole thing, and maybe I need parentheses around this times 10 to the, no, it's not like that. You just do 6.67 E negative 11. That's it. It knows what that number is. Well, I didn't actually do a calculation with that, so let's multiply it by 1. It knows that that is scientific notation. It will keep track of the scientific notation. It treats this whole thing as one chunk that you do not have to worry about. Google also knows your basic functions that you'll need. So we already saw power. So like if I take 3 caret 2, that's going to do 3 squared to give me 9. I can also do other functions, like say, for example, square root. I can do square root of 3, That'll give me the square root of 3 there. I can also do 3, of course, to the 1/2 power. That's another way of doing square root of 3. That actually, if we multiply those together, that'll be even more impressive. It's also kind of like a code in that you can put in spaces to make it more readable. So if the text is getting very crowded for your eyes, you can put spaces between your terms like this, and it'll treat it just fine. Boy, that is the most random autocomplete I have ever seen. Let's see, you can also, we talked about square root, you can take absolute value, so I may take absolute value of -1000. That's going to give me 1000. I can do exponent. I can do exponential of 1 to give me e, right? There's your Euler number e. I can do e to the 10th power to get e to the 10th power. Pretty cool. What else can we do? It knows trig functions, so we might try sine of 0. Sine of 0 better come out to be 0. It certainly did. You'll notice that it defaults to radians. So this calculator is written by mathematicians, so it defaults to radians, not degrees. You can change that, though, just by typing in degrees. Now, that happens to be the same because those are the same value, but like I might do sine of 90 degrees comes out to this 1 here. And that actually brings us to our next thing that you can do with this, which is you can put in units. So for example, I can put in sine of 90 degrees, or I can put in sine of 90 radians if I want to be explicit about it. It's a random number because 90 radians is not really a significant value. You can, if you do the arc sine, so let's say I take the arc sine of 1, that's going to give me a pi over 2, but let's say I want that in degrees. I can say in degrees. Right, so if you want to change the radians into degrees, just type in degrees at the end and it will convert the units for you. I can't take arc sine 10. Let's try arc sine of 1/10. There we go. That is 5.74 degrees there. It does this with basically any units you can come up with. So let's say you're doing a velocity problem and you have that something moved 3 meters in 2 seconds. So you need to do 3 meters divided by 2 seconds. It will combine that into 1.5 meters per second. Pretty cool stuff. You can do this with acceleration too. Let's say you're doing your velocity here as 1.5 meters per second, and you need to divide that by the amount of time it took to get that fast. Let's say it took you 2 seconds to get that fast. It will combine those into meters per second squared. So not only does it have all these units and know what they are, it knows how to combine and cancel them. So you have 1.5 meters per second divided by 2 seconds, gives you 0.75 meters per second squared. So I am usually very much a stickler on my students' homework for keeping track of units, but if you just put the units in here, it will keep track of them for you. It's magnificent. You notice I can even mismatch the units, right? So I have seconds abbreviated as an S here, and I can have seconds spelled out here. It knows that those are the same thing. I can even combine my units. Let's say I have miles per hour in 2 seconds. It will combine that into 0.33528 meters per second squared. It will even handle the conversions for you if you're working with miles and hours and fortnights. It will give you this miles per hour per second in units of meters per second squared. Well, what if I wanted it in miles per second squared? Okay, I can change this to miles per second squared. And there you have it. You have miles per second squared. Or maybe you need feet per second squared. Feet was not even in the recipe here. I can get 1.1 feet per second squared here. You just say in and then the combination of units you want, and it will spit those out. So let's take another example. Let's suppose I am working with the Coulomb force, the electric force between two charges. There's a electric constant here. There's Q1, Q2, and then divide by the distance between them squared. So what I could do with that, I could take the K value, that is 8.99, what is that? That's in newtons meters squared per Coulomb squared, and it knows what all these things are. They're standard abbreviations that everybody uses. I'm going to multiply by the 2 coulombs here. What is the charge of a proton again? It is 1.6 times 10 to the negative 19 coulombs. You notice I'm using my E to the negative 19 to represent times 10 to the. Let's repeat that. Another nice thing about working on Google, you can copy and paste your calculations. It's a little bit more difficult to do that on a graphing calculator. I don't even remember whether you can do that on a graphing calculator. And let's say they're separated by 1 nanometer, and I got to square that, right? So I run this, I will get my answer of 2.3 times 10 to the negative 19 newtons. It all combined into newtons. I only had 1 newton up here, and the rest had to cancel out, and it took care of all the cancellation for me. It took care of the nano. It knows what nano is, right? Let's suppose we change this to meter instead. That's a drastically different number now, so it knows what nano is. It knows what all your metric prefixes are. I could even write this as a nanometer here. Let's suppose I made a mistake with this. Let's suppose I left off the square, right? Like we do all the time on our homework. Then it comes out in joules, right? Because that's now an energy, not a force. And I say joules. No, I was supposed to get newtons. Oh, wait, that's right. I forgot to square this. There you go. But then it gets even better because Google knows what a lot of these values are. So for example, if I were doing this problem, I don't have to type out these values. I can use the values that Google already knows. Now, it doesn't know the electric constant K. It knows the electric constant epsilon naught, and K is 1 over 4 pi epsilon naught. Epsilon 0, I believe it knows what that is. Let's double check, make sure. It knows it as electric constant. So if you ever don't get the value that you're looking for, just try a different name for it. It doesn't know all the names, but it does know at least one name for everything that you need. Yes, here we have 9 times 10 to the 9, so this is 1 over pi epsilon naught, just like you're accustomed to seeing in your textbook. Yes, it does know what pi is as well. I can then take that and multiply it by the next piece, the elementary charge. We're doing that one twice, so let's have elementary charge times elementary charge, and then divide again by 1 nanometer squared. Now, this is even better than the last one, I think, because I'm not having to worry about what the numbers are. I just know that I need 1 over 4 pi epsilon naught. So I tell it 1 over 4 pi epsilon naught. I don't need to waste my brain processing power recalling what epsilon naught is. Same thing with the proton charge. Why should I recall that when I can just ask Google for it here? And then I have my 1 nanometer squared on the bottom. We'll hit enter. And lo and behold, we get our force again, 2.3 times 10 to the negative 10 newtons. And it does this with a lot of stuff. So let's say, for example, I want to do E equals mc squared for an electron. So I might take the electron mass times speed of light squared. I can even put the square around a name here like this because it knows to treat that as a number. It gives me the mass energy of the electron in joules, 8.18 times 10 to the negative 14 joules. Let's suppose I'm working in a modern physics class, and as we often do, we need to work in electron volts. I can ask it for electron volts, and it will give me this mass as 511,000 electron volts. I guess that's 511 keV for the electron mass energy. Yep, there it is, kilo electron volts there. So to conclude, I strongly recommend that physics majors use Google as a calculator. When you need to do these quick calculations at the end of a homework problem or for an estimate, it's just so much easier to type speed of light than it is to make sure you get out all the significant digits you need. This is especially useful in a modern physics class where you're using these constants all the time. We're going to be using electron mass, speed of light, Planck's constant over 2 pi. You can type in h bar and it knows what that value is. So I strongly recommend using this instead of a graphing calculator. It makes life so much easier for you when you have all of these physical constants flying around.